In this video, we're going to look at some of the really basic trigonometry, although we do have some more difficult questions towards the end of this video. We're going to just deal with trigonometry of right triangles, and we have an example of a right triangle here. It's a right triangle because there's a right angle right here. For right triangles, what we do is we label one of the angles as theta, right? So we're interested in that angle there. Now, not touching this angle is the side which we call opposite. So opposite, the side that's labelled opposite, is not touching this angle. The hypotenuse is the longest side of the triangle. It's always kind of not touching the right angle. And then the adjacent goes between the right angle and the angle that we're interested in. Adjacent is just another word for next to. So if your angle is here, then not touching that angle would be over here, would be opposite. Right? So opposite this angle, sort of looking at it from over here, would be the opposite side. Hypotenuse again is the longest side, and adjacent goes between the right angle and the angle that we're interested in. And what trigonometry is, or part of what trigonometry is a way of getting sort of missing information. If you're given the angle perhaps and you're given one of the sides, then you're able to find one of the other sides. And that's what right-angle trigonometry is. To use it, we usually need calculators because your calculator has a sine button, a cosine button, and a tangent button on it. In order to set up equations, what you need to remember is that the sine of an angle is equal to the opposite over the hypotenuse. So the sine is equal to opposite over hypotenuse, opposite over hypotenuse. So if you're looking for the sine of this angle here, it's this side, the opposite, divided by the hypotenuse. Likewise, the cosine is the adjacent over the hypotenuse, the adjacent over the hypotenuse, if this is your angle. And the tangent of this angle is the opposite over adjacent, opposite over adjacent. And a way of remembering that these three things is this kind of nonsense word, SOHCAHTOA, this word here, because the sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, how can we use that? We can use it to answer questions like this. If you have a right-angle triangle and the sides are, as they are marked here, 5, 12, and 13, if someone asks you to find the sine, cosine, and tangent of this angle here, the angle at CAB, notice that CAB has the angle actually at A. The sine is going to be, well, before you think about what it should be, think about what is opposite this angle. What side is not touching this angle? It's this one over here. So this is your opposite, this is your hypotenuse, and this one here is your adjacent. And what we then do is just write the sine is equal to the opposite over adjacent. In this case here, the opposite was the one not touching theta, which was 5 divided by the hypotenuse 13. And if you do that on your calculator, 5 divided by 13 is 0.3846 approximately. In the same way, cosine of theta is adjacent over hypotenuse, which would then be equal to, in this case here, adjacent is 12, the hypotenuse is 13. So in this case, it's going to be 12 over 13, which is 0.9231. And we've already got the tangent in there. It's again the opposite. So this side here is opposite the angle, divided by adjacent. 5 divided by 12. And then it gets more useful for this kind of question like here. If you're if you've got an angle, right, BAC equal 27 degrees, and you're given one of the sides of a right-angle triangle, then can you find BC to three significant figures? Well, the first thing to do with a question like this would be to draw the actual triangle. And the actual triangle should look a little bit like this. Now, it looks like this. If you're trying to draw that, try and draw this angle here first. Angle ABC is 90, so your B should be labeling the 90 degrees, right? Your B is at the 90 degrees. And then AC is equal to 18. The AC is going to go between the two other sides. Put an 18 next to that. And the 27 degrees is at angle BAC. BAC is that angle right here. It has A, it's the angle at A. Okay, once you've got your drawing, you're then ready to think about what these sides are. This side here is your hypotenuse, because it's not touching the right angle. We're kind of interested in this angle here, and we're interested in this side here, BC, because that's what we're asked to find. So think about how this side here would be labelled. Would it be labelled adjacent or opposite? It's not touching this angle, so it's the opposite. So what we were going to use here, out of sine, cosine and tangent, which one involves the opposite over hypotenuse? It's the sine. So we then have this equation set up. Sine of 27 degrees, again, is opposite over hypotenuse. So in this case here, that means BC, side BC, divided by 18. Now, using your calculator, you can get some information about what the sine of 27 degrees is equal to. The sine of 27 should be something that you can calculate, you can put into your calculator, but BC is going to be 18 times 27, and if you do that calculation, what you should then get is 8.17 centimetres. Right? So we've used trigonometry there to find one of the sides, given that we've got an angle and a side already. We've been able to find out the length of this side here. Now we're also able to use trigonometry to find an angle if we're given at least two of the sides of the right-angle triangle. First of all, relative to this angle here, can you think about what this side and this side would be? Would this side here be opposite adjacent hypotenuse? This side opposite adjacent hypotenuse? Which ones would it be? Well, this angle here, this side here would be opposite this angle. So this one's the opposite. This one here, well, it's the adjacent, and this one here is the hypotenuse. Right? So I always think of the hypotenuse as being the first one to think about. It's the longest one, it's the one that's opposite that, so it's the easiest one. So this is the hypotenuse. This side isn't opposite this angle, it's going between that angle and here, so it's the adjacent. So we have the adjacent and we have the hypotenuse. Think about your saw katoa. Which one involves A, adjacent, and H, hypotenuse? It's the cosine. So we set up the cosine equal to adjacent over hypotenuse. Adjacent over hypotenuse in this case is 8 over 20.5. So if you want to then find out what theta is equal to, what you've then got to do in your calculator is not cosine of 8 over 20.5. What you've actually got to do then is the inverse cosine. On your TI-84s, you'll get the inverse cosine, the thing with the -1 there, by doing the second button and then cosine. So the inverse cosine of 8 over 20.5 should give you the the value that you're looking for, 67.0 degrees in this case. Now, what you should do is just try that on your calculator for yourself, because your calculator can measure things in radians or it can measure in degrees. And you need to be in the right mode. So if you want your answer to be in degrees, like we have in this case here, or if you're given information that's in degrees, you need to be in degree mode on your calculator. So you would need to, on your calculator, press the button mode, and then go down and select degrees before you enter this calculation here. In example 4, we're given a triangle and we've got to just find the length of this side here, the length of AB, given that we've got this being 10 and we've got this angle here. Okay, now again, it's useful to think about what these sides are. This side here is opposite this angle. This side here is adjacent to this angle. Opposite, adjacent, think about SOHCAHTOA. The opposite and the adjacent is the tangent, TOA, opposite and adjacent. So, if you're setting up an equation for that, your equation is going to look something like this. Tan of 35 degrees is equal to the opposite, which is 10, divided by adjacent, which is AB. We can then rearrange that equation. We can rearrange it like this, right? So the AB is equal to 10 divided by tan of 35, and you'll get 14.3 centimetres by doing that.